What's going on, guys? In this video we are going to talk about translation theorem in S. Before we talk about that, let's look at this derivation. When we have a derivation of f of x, it's equivalent to f prime of x, and if we take the derivative of g of x, that's equivalent to g prime of x. When we have two functions of x, and if you take the derivative of that one, that's going to be a chain rule, right? Nice. We will have f of x g prime of x plus g of x f prime of x. Here what we are going to do is we are going to compare the same thing for the Laplace. For example, if Laplace of f of t is equivalent to f of s and Laplace of g of t is equal to g of s, but if you take the Laplace of f of t g of t, there's no equation for that. It's not like derivative, so there's nothing for that. That's why we are going to do the translation theorem. In translation theorem, we have that previously we learned if you have a Laplace of f of t, that's equivalent to f of s, that's equivalent to an integral 0 to infinity, improper integral, e power negative st f of t dt. Okay, so here what we are going to do is we are going to see how can we find the Laplace of e power at f of t. If we have a function, like if we have two functions together, how we can do that? To do this one, what we can do is we can think this one as altogether f of t. Instead of this f of t, we replace this one. If we do that, this is going to become f of s. This is going to become 0 to infinity, and we will have e power negative st. And instead of this f of t, we are going to replace that one with e power at f of t. Then we will have dt. Here we can combine this e power negative st and e power at together. If we combine and factor this one in a better way, this is going to become e power negative s minus a t f of t dt. And here you can compare, like when we have this one e power negative st, that's equivalent to f of s. Here we have, instead of this s, we have s minus a. So it means this whole thing is equal to f of s minus a. That's what translation theorem says. Now let's look at an example for that. Here we have a problem. We are going to solve this one using the translation theorem. First, whenever we have a situation like this, first we can deal with this sine 40. If you have sine or cos, deal that one first. Then you can consider this e power 2t. So sine 40, if we take the Laplace of sine 40, Laplace of sine 40, we know that Laplace of sine 40 is equivalent to b over s square plus b square. In our case, b is 4, so this is going to become 4 over s square plus b square. B is 4, so b square is 16. This is sine 40. Now to convert this, after that, if we consider this e power 2t, e power, here a is 2, right? So we have to put s minus a. This is f of s, and if you put f of s minus a, this is going to become, instead of this s, we have to put s minus a is 2, so s minus 2. If we rewrite this one as 4 over s minus 2 whole square plus 16, and that's going to be the answer. We just have to, instead of this s, we put s minus a. A is whatever the value we have in the power of a, actually e power, so whatever the value that's multiplying t, that's our a value. And if you subtract that and square and put it instead of this s, that's going to be the Laplace transform of this whole thing. And that's how the translation theorem works. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.